want to thank everyone for taking the time out of their schedule to come see us today. My name is Brent. I'm here with my partner Alejandro, and our faculty advisor is Dr. Velati. We're going to present to you today our solar-powered attic fan. Our motivation behind this design was basically the problems that we can reach temperatures up into the 140-degree Fahrenheit level, especially in the summertime in South Florida attics. What this problem poses is that we get infiltrations and air leakage into the household, resulting in a higher air conditioning bill, putting strain on the air conditioning system. Current fans that we see in production are visually unappealing and do consume power, so we're hoping to try to improve on this design in hopes to expel the hot air out of the attic more rapidly and efficiently. Through this design, we plan to implement solar voltaic cells, particularly a geometrically shaped tetrahedron. We'll explain the reasons behind that later. We hope that will charge a battery, which will then in turn govern a motor-driven fan that will aid in expelling this hot air from the household attic. The reason we chose this pyramid and tetrahedral design is basically it's applicable for any type of orientation on a household roof. With modern day fans, solar-powered fans that are currently on the market available through Home Depot and Lowe's, they're very planar and one-dimensional, and they have to be placed in a certain position on the roof where the sun may be oriented on your house. The problem is this may be unappealing when you have, perhaps if your house is in the south and the driveway faces this way, you may not want to have this fan on the house where your neighbors can see or possibly in the backyard. What our design allows for is that we can put it next to a chimney or hidden anywhere on the point where it is kind of out of sight, out of mind, yet still getting full maximum exposure from the sun. In addition, we want to obtain the maximum surface area while minimizing the volume as far as solar absorption is concerned. This way we're able to make the device as small as we can, yet still accurate. General components are going to consist of a thermistor type technology in which it's a resistance which varies as the temperature increases. The RPMs on our motor will hope to increase as well, thus kind of allowing the system to adjust to the needs of the heat of the attic and increase its power or decrease depending on the temperature in the attic at a certain time of the year. Our general design will consist of this. It's essentially going to be a geometric tetrahedral shaped solar cell. We're going to have electrical inverters and AC controllers. Underneath will be the fan, which will expel the air from the attic. This will be governed by a motor, which will then in turn be charged by the battery, which will be charged by the solar voltaic photovoltaic film. It'll be easily installed on the roof. Usually it can replace an area where you have a current fan, just kind of go right over it. I'm going to let Alejandro explain to you the global components involved in this project.
The ethics and sustainability of the project, we have a current part manufactured on the market right now, like Airband, Blue Hang, Sunlight, Attic Air. And also we found some current patent related to other products, like for example Airband, which currently hold patent pertaining to rings. For example, the cable mounted power attic is one of the products that are in the market. You can find in Lowe's or Ace. This is one of the products that we can find already. About the environmental impact, most of the part doesn't pose any threat to the environmental. Like for example, the battery is completely rechargeable. We try to choose a battery like lead acid, which has a working life for about 15 years, and also is 97% recyclable. Also, we're planning to select a fan that is made of aluminum and also is 100% recyclable. Runs on direct current, so we don't have to work about voltage. Of course, that's why it is ideal for any suitable geographical location in which needs arise. For example, we have some examples of the part that we plan to use, like an electronic converter, electronic controller, the thermistor, the rechargeable battery, the driver fan, the motor, the pyramid housing cells, and of course, we made a research about the cost of the part, and we come on this cost. It's around $280 the complete cost for all the parts. we're planning to do this project in 16 weeks. Like you see, we're going to take some time, more time doing the development and assembly. We're planning to do the testing in the beginning of October to make sure that everything is going to be okay at the front. So, any question?
All right.
Yes.
Talk to me about the engineering analysis you plan to do on this project.
Okay, what we've already initially started, we've taken 3 household attics ranging from about 140 cubic feet to over 300. We're kind of waiting for the summertime to get it full effect so we can get the maximum temperature in the attic and see what we're going to have to worry about expelling. We've taken fans, motor-driven fans through alternating current, placed them on the roof and expelled air over about a 15 to 30 minute time period. And unfortunately, we've only gotten about a 7 to 8 degree difference from when, with no ventilation to our ventilation. That's something we're going to have to work on to see maybe we need a more powerful motor, more fan blades, bigger fan blades, more RPMs. Once we determine this, then we know how much current we need to drive a given motor and what type of current is going to be needed to generate through the photovoltaic film and charge the battery. So essentially, we have to keep getting air out of the attic and determine what kind of motor we need first before we can proceed forward. So that's our testing.
Well, can't you, ahead of time, knowing the volume of the attic, the temperature of the attic, and the CFMs of your fan, determine how many air changes you're going to have in the
Yeah.
attic and figure out how much temperature you're going to drop without doing the testing?
Ideally, we should. We don't want to put all our eggs in that basket and say that, yes, we made these HVAC calculations that we learned last summer, get this number, and then have it, for whatever reason, not be valid. And then at that point, we're stuck with a motor.
Well, you have to find out, though, because the thing is, that's part of the experimental. You're doing
course.
the experimental only.
Mhm.
You got to also figure out what to expect.
Sure. But part of
Because
the reason
when you size a motor or your fan,
Mhm.
you have to know how many CFMs you're going to need,
Sure.
right? So
Yeah,
have you
that-
thought of that at all?
Of course
So I
we
mean,
thought
at the
of it,
end of
yeah.
the day, you do the theoretical piece, you do the experimental piece, you correlate the two, and then you explain the differences.
We just
Right.
had an opportunity to work with an HVAC professional when we came up with the idea. So we had the opportunity to go into homes and do this right away. We figured we'd try to do this now, we'll do the calculations, see how close they meet. Nevertheless, those are going to be an integral part of our final report. So that is main of our master plan, yes. For now, this is all the testing we've done.
All right.
That an answer to your question.
Okay. With your design, you said you would like it to be expel air to the attic more efficiently.
Yes.
What's your definition of efficient?
Better than the modern day fans are right now. We want to use a more powerful motor. We want to use the geometrically shaped solar photovoltaic film so that, like I said, we can place the item on the roof anywhere without being confined or restricted to where the sun is going to be. So in that sense, also, which I didn't mention during the presentation, as the volume decreases, as the size of this tetrahedral goes up, we're hoping to achieve a funnel-like or jet effect that will help expel the air as well in conjunction with the forced convection from the fan. So that's our goal as far as improving.
And how do you know the other existing fans that are out there? I mean, so did you
We've
react?
gathered our data from HVAC professionals in the field that have been working for 20, 30 years, and they haven't seen them in any South Florida homes.
So you want to be
so-
more efficient than those fans?
There's a reason these haven't taken off in the market, probably several very good reasons, and that's what we're hoping to improve on.
Now, the question I'm having also is the power you need for the fan is a DC motor, so you're going to be running off the battery 100% and then charging the battery from the sun.
That's our ultimate goal,
So you've calculated how much power you're going to be using. Is that enough compensated by the sun to charge the battery and not run out of battery after 3 hours?
yes. That's what I was just saying earlier when I said we tested on 3 attics, and we're trying to determine the size and the power, the current needed by the motor to operate to that. That's going to be the whole basis for the volume, the surface area of our cell, is once we determine the caliber of the motor that's required to perform this.
And it's your assumption that motor will run 24 hours a day?
No.
Well, I mean,
Depending on
in
the time
the
of
summers, it's as hot
At
at
night,
night as
yeah.
it is during the day.
Sure, and the attics
You get
can hold a
more
lot more
solar
humidity as well. Is it going to be spinning 24 hours a day? We don't know yet. We are hoping that the thermistor will allow a certain sensor to go off when the temperature reaches a certain range, which we don't want, and at that point it would run. Running 24 hours a day is probably wishful thinking as far as the strain it would put on the battery, so we're going to hope that we don't have to go that route.
How would you control at night not running?
We don't say that we don't want it to run at night.
Oh.
We're going to have a thermostat that's going to tell us the temperature of the attic is this range, and that will govern the thermistor or the inverter to govern the RPMs of the fan and kick in when it needs to and to be quiet when it doesn't have to.
And you would use multiple fans, right? In different-
Right now, we're ideally one fan is what we're testing with. If that doesn't give us the results that we want to achieve, we're going to have to go back and basically reiterate our
Well,
design.
that's what I meant by calculating ahead of time. I mean, I think it's a good idea. I think
Yeah.
it's a good exercise as well. A lot of this stuff, you don't have to put one fan on there and realize that it doesn't work.
Right now, we can do that because, like I said earlier, we have an HVAC professional that's allowed us to give us this opportunity to do so. But we're not going to order any parts without doing these
Oh,
CFD
no,
calculations.
that's not what I'm saying, but if I know, for example, if I know I gotta get, so many exchanges an hour or whatever to get how much volume of air out, one might never be able to do it, so you might be better off. So you gotta think about that, and I would compare it to electrical product as well, including the cost of the electrical fan to run, you know what I'm saying? Things like that, I mean, that's something I would like to see in a report. And
Does it outweigh the current
Right,
cost of what
right,
it would cost?
things like
Yeah,
that. And
right.
I think that design it's pretty good for hurricanes because it's pretty symmetrical, air should go through it with no problem, so that you could add that to that.
But I also think you need to do a stress analysis to prove to us that
True.
it's going
It's not
to be
gonna fly
able
over
to
it.
sustain hurricane-style winds without creating a nice big hole in my roof.
Right.
That then becomes the ability to peel my roof.
Well,
Right.
yeah, that's something that modern day fans have been able to go off without a hitch. You do hear about these happening during hurricanes. If I may add, there's one question that nobody's asked is how are we going to stop water from getting into this? Because we do plan to have an opening on the top where the air is going to be expelled. I'm going to kind of ask my own question that nobody's mentioned. We're going to hope that the air is going to kind of come out and prevent that, but we may have to implement some sort of fiberglass mesh or semi-permeable membrane that will allow one-way gas exchange but not allow fluid. to
Oh,
get
I
in.
didn't know you had a hole in the top.
Yeah, I
I
didn't
thought it was
mention that
leaving
in the-
through the sides.
Yeah, no, it's gonna, we aim to come in on the top. The current day fans, they do expel it from the sides.
Okay.
So, but you can still get water in there, and I haven't looked at them close enough to see how they don't. But if we're gonna save someone $500 a year in FPO bill, but then they spend $10,000 to repair the mold that we just caused them in their attic, then we'd have to.
So you have an idea how much you're gonna save?
No, we haven't done those yet. Like I said, everything is riding on the motor and the testing we've done in the motor. We're waiting for May or June to come around so we can get those maximum temperatures and see what we're dealing with.
But I mean, that exists. I mean, you should be able to go to a
Weather
table today on
database.
temperatures, typical temperature profile.
Yeah, I mean, I guess ideally we could purchase one for $350 and try it out and see how does that
No,
compare.
no, no, no.
No, it's talking about
The-
database, weather database.
The temperature
database?
in a typical attic. you can find-
140 degrees roughly in South Florida, you can easily achieve that. Have I been in an attic and gotten 140 degrees on my reading? Not yet, but I hope that they do get that high because it'll give us more to work with.
But you could do numbers with that range, right? Just start doing analysis and do a curve and a chart according to how much temperature
Yeah,
and.
what they're saying is that there's data out there that can drive some of your analysis now.
It'd
So
actually
you
be more
don't-
reliable
Right.
because it's
It's
taken
natural.
over a period of time, it's taken over multiple years.
And it's averaged as opposed to one season.
Yeah, like I said, the testing that we've done, we had an opportunity to go into 3D people's homes and perform this. That's why we've done this before the calculations. They will be the backbone of our report, I can guarantee you that, next December.
Are you gonna build one of these?
Yes, sir.
Okay, so you'll be ultimately able to test it completely.
That's our goal, yes. We hope to have that done by the end of the summer. But of course, we're allowing for setbacks or redesign potential or anything of the sort.
So in December, we'll see one of these.
Yeah, when it's cold. That's our master plan.
Okay, well, thank you very much.